be ready in a couple of seconds. Okay. Hi everyone, welcome to this LinkedIn live session with Alex from Polity. Hi Alex, thanks for having us. And yeah, I would suggest maybe let's start with a brief introduction from yourself so that people know who is on today and that everyone gets a better picture of what's going to happen in that.
Well, thank you very much, Kevin, and it's great to be part of this podcast. My name is Alex. I am the vision officer and investor in the Polity project. I've spent 3 decades in finance. I was trained as a civil engineer in the 80s. I worked in the field before moving to finance, and for the last 5 years, we've been building Polity, which is an enterprise product for regulated financial services. Thank you for having me on.
So definitely a very interesting topic to, or let's say a very adjacent topic or company to our topic today. Like did Agile break engineering and can AI fix it? So that's basically our core topic for today. And we have released 3 articles so far on that topic. So my question for you, Alex, is like from your perspective, what did Agile actually try to achieve?
So what AI tried to achieve, or
Agile,
if I understood,
like the
so
principle itself,
agile.
yeah.
Well, I think
Agile.
agile. Well, and obviously this is an important topic. Agile optimized delivery. It was a major revolution in how people actually build software, which was principally focused on the engineers themselves, and it did improve the quality of the work. It did improve coordination. It did improve the velocity of delivery, but it also meant that it created, or it has propagated a system which eventually became something which the Agile founders did not envision, and what they argued that wasn't really Agile. So a very important step in software development and evolution, highly consequential for everything we do even today, and obviously part of the history, but also has to be considered in the wholeness of software as a discipline, of engineering as a whole, rather than just a specific topic.
Yeah, obviously, any engineer, I would dare to say, who has worked in a large organization has faced exactly those struggles, right? You have to work with structures and processes that don't really contribute to engineering velocity, right? But actually slow everything down, and you basically run in circles in a lot of cases. So you basically already outlined where we went wrong, but where do you see the issues, especially in the enterprise context, so to say?
Well, I think enterprise adopted Agile when it became a brand, when the craft was turned into commercialized, sellable, and basically packaged product. Obviously, management of a number of enterprises took it on without understanding challenges in terms of adoption, without understanding the initial purpose, because Agile was initially developed for fairly small and nimble teams, which would typically be co-located, where people would interact directly. It did not involve organizational massive hierarchies, didn't involve senior management, didn't involve the kind of decision making large corporates typically have to exercise or bound to exercise. So a lot of Agile philosophy was kind of lost in the process. The ceremony, which could be measured, could be basically KPI, became adopted, whereas the essence was being lost and has been lost eventually, because these things became just another way of gating software delivery and putting a very nice facade on the same old practices without any real change and without improving software. In fact, I think what we've seen and what I've personally seen, because I've been involved off and on in software for the last 3 decades, is that it helped in a way justify the erosion of requirements. And as humans, we always try to minimize, effort, minimize energy consumption. That's only normal. And Agile kind of seemed to have given these managers an excuse not to work on the architecture, not to focus on specifications, not to do a lot of thinking up front, thinking and considering that everything will sort itself out. And it doesn't do so, particularly when complex and critical systems are involved.
Yeah, I mean, funny enough, you see that with a lot of software agencies too, right? They basically say we are agile and we do it that way, but in the end, it's just a missing process. It's just missing like how you actually should build software, right? You still need some kind of structure to build something people want, and of course, secure, stable software that then actually fits the acceptance criteria, right? Um, from that perspective, would you say it's more or less agile itself that's the problem, or more or less the implementation of
Well,
it?
I think it is by and large implementation. And again, the ideas of Agile are kind of timeless, like principles of putting the team and the customers over the tools and frameworks and whatever. It all makes perfect sense. However, it did not really specify implementation, didn't go into implementation. It allowed very wide and divergent interpretations, and obviously then it was captured by the commercial industry, which packaged it, created ceremonies, then codified ceremonies, and ceremonies were measured. Obviously, could be used for reward distributions, for bonuses, for performance assessment, and that obviously kind of ossified the entire idea. The idea of being agile is very important, because if you lose agility, you lose life. Basically, we are agile because we are alive. And if we aren't, obviously, we can't provide or we can't produce anything of serious sustainable value like software. So I think implementation is the key issue, and also conflation, because Agile did not actually focus on the entire product itself. It focused on the delivery part of a product. And I think what has been progressively lost over the last few decades is the understanding of the product as a whole, where Agile or the delivery methods is just a part of, a very important part, but just a part of, and cannot replace the whole. And particularly this is relevant for enterprise software, where the coding part itself is only between 10 and maybe 25% of the total cost, and the costs and investment in requirement specification, architecture, in testing, in validation, exposed greatly exceed the cost of producing software. So in a way, the emphasis just on delivery doesn't really solve the whole problem. And in order to solve it, we have to step back and look at the wholeness of the product itself. What are we trying to deliver? Why? And these are, I think, the questions which got lost and progressively got outsourced. And what I've also seen is that people obviously try to progressively outsource requirements generation and thinking as a whole. And that became basically an issue, because if you don't know what you want to do, there's nobody on earth who would tell you what you need to do. They would basically give you a story which may not be your story. And obviously, a lot of misunderstandings arose and a lot of issues came through it, because the people who commissioned software, who were in charge of actually specifying software, didn't really take time to define what they wanted to achieve as the end result.
Mm-hmm.
So a lot of it actually rests with the clients and with the folks who were in charge of basically conceiving what they needed to achieve, rather than with the delivery teams.
Yeah, makes a lot of sense. Um, Let's maybe look at a very common example of, let's say, a corporate or like enterprise company. They have certain processes in place, like basically do agile software development, or at least they say so. Um, what would you tell them? Like, how should they maybe try to change that process? Like, we all know change management is super challenging too. In a maybe non so like less invasive manner, or like how would you attack that? Let's put it that way.
Well, it's an interesting challenge, and we've actually faced it. I've personally faced it as trying to build and run a small engineering organization. Where do you actually start? How do you do it properly? And obviously, at the beginning, we made all of the typical mistakes. We outsourced thinking. We tried to kind of save on the preliminary work just to get as fast as possible to the end result. Predictably, in a complex system, it didn't really work very well, but it was an invaluable learning experience. So I can't really tell and recommend to companies how to do it better, because every company is unique, and I think we have to recognize it, and every software process for a particular company is unique to it. So beyond the first principles, so the companies themselves will have to design it. What I can tell is our experience and what we've learned and what we've taken now as the rails we need to follow in the way forward, and maybe some of it can be relevant for other organizations out there. So the first thing is what we kind of adopted, and this is also nothing new and nothing challenging, is the think first approach. And it's very simple. Don't engage in something you do not understand. If you have no idea what you are trying to build, don't. And that's like, really simple, really straightforward, and very, very hard to do, because the incentive, the push, the pressure to get things done before things become clear in your head is just overwhelmingly strong, particularly in a layered organization where, a lot of people are pushing, okay, we need something, we need delivery, we need it yesterday. But you have to pause and you have to, okay, do we actually know what we're building? Do you know why we're building it? These are very important questions, why and what. And then do we know how we want to build it? Because there are different ways, different approaches, there are different combinations, in-house, outsourced, mixed, you name it, all sorts of things. So before you know it at a higher level, at a strategy level, and what this product will do for you or for your companies or organization strategy, there's no point of engaging in anything. It will likely be a waste of time and money. So that's a very simple one. Again, very hard to adopt, and it's got nothing to do with software itself. It has to do with the way we approach business and enterprise. I think the second important point is actually, once we answered what, and we've answered why, and we've built a solid case, is to understand the optionality we have, how we can solve problems. And sometimes there are very complicated solutions offered for simple problems, and you always have to use the Occam razors approach, where you kind of, shed all the complicated solutions for the most efficient and for the simplest one under the circumstances. And it's not necessarily the most, and this obviously there's political pressure and whatever, and people are sometimes partial to certain tools, certain frameworks or whatever, and abstracting oneself as a purchasing manager or as a manager of this project is very hard at times, kind of resisting this pressure and see what's the best way, what is the most efficient, what is the easiest, what is the most logical way to get from point A to point when we have the software and when it's integrated with our organization. I think the other thing is always to consider that it's never static, and people tend to regard projects as a static thing. Okay, we need to build something, let's build it. Well, we've built it, we can forget about it, we move on. It never happens this way, particularly with software. It's a continuous process, like documentation is never finished. Documenting a project always continues throughout its life cycle. Technical debt and now of late comprehension debt always need to be served and serviced, and that's an important point. So you actually never have a project which is completed. When you complete a software project and take your hands off, it actually dies within a fairly short period of time and becomes unusable. And may have to be rebuilt at a considerable cost. So understanding that once you engage in something, this is a long-term commitment and long-term engagement. It's not a one-off, I think is very important. I mean, I would like to also mention specifically the documentation part and writing part, because we tend to kind of move into action, because obviously the culture, the commercial reality revolves around actionable things, about products, about deliverables. That's what people are rewarded for. The processes are not necessarily the documentation, requirements, specifications, whatever. They're not very exciting. They're not necessarily rewarded because nobody really sees them. Yet without them, you can't develop and deliver the final product. And focusing on processes and designing and implementing strong processes, including documentation, including architecture and requirements, is really an essential part. And if we skip on it, we'll pay double or triple price exposed, again, in this dynamic environment where you deliver something doesn't work and you spend the rest of the year debugging it, and then obviously it gets obsolete, and then you have to replace half of the frameworks because the ones you put in have already been become obsolete, and on it goes ad infinitum. So I think this is a very important part. And again, it takes a lot of kind of discipline, and it takes willpower to do it, because it is very tempting just to skip it and okay, let's get something done because all our clients care about is something they can actually click on. But if you really into long-term value optimization over the entire life cycle of a product, which can be years and even sometimes decades, then this way of thinking is actually much more costly than the more front-loaded thinking process with requirements and architecture up front.
100%. In the second article, you talked about the product software factory. Like, what is it in your own words?
Well, it's an interesting concept, and it first emerged almost 50 years ago at the NATO Software Conference in 1968. And the idea was very appealing. Let's take William Taylor's principles of industrial engineering and apply them to software. And on the surface, made a lot of sense because, yes, you can split work into parts, and it is possible in software. Yes, you can design individual workflows, and these workflows can be codified. And yes, you could separate planning from execution and effectively focus on requirements generating and kind of front-loading the thinking process, the craft tool to speak, and then kind of, just send it to the floor where people will build it. Very appealing, and obviously been implementations, and we've seen it in Japan, particularly in the 80s, with the large software companies like Toshiba and NEC implemented at scale. Massive factory at the time actually was considered to be almost like an industrial threat, elsewhere, particularly in the United States, and they looked at it and researched it. It actually never worked in the end. There were many reasons. But one of the reasons is that this approach to software engineering, software development has proven to be uneconomical given the tools and frameworks available at the time. And even though you could actually do it, it was not really workable on the scale the software was needed. So the demand created for software, particularly as we went into the digital age in the 80s and the 90s, far exceeded the capacity of these production facilities. And the idea that humans could produce, update, document every single component, and every single component could be cataloged, and then they were all assembled. They worked in theory, never worked in practice at the time. But it wasn't because the ideas were wrong. It was because the delivery methods at the time weren't really fit for the purpose.
Speaking of delivery methods, obviously we have to talk about AI. Does it solve that issue?
AI solves a great deal of it, doesn't solve it all. I think AI and Web3 and systems engineering as the overriding kind of discipline which pulls it all together solves it. But AI on its own doesn't. Web3 on its own doesn't. And obviously systems engineering, the abstract doesn't solve it either. So you have to actually combine these three. It all starts obviously with the system as a whole, and the system is a bounded set of components which interact with one another. So at the most, the sort of highest level of abstraction. And then engineering system is the same with a purpose. So you have a purpose, obviously, which the system has to achieve. Well, very important part of any system, particularly artificial or engineered systems, is governance, which is the exercise of authority over these components and over these parts. Well, how do you get the system to do things you want it to do, or the purpose you put in? So once this is understood, obviously there are, and this is where governance and assurance come along, because without that, if you simply indicate intent to AI and let AI wipe code and derive from the intent, whatever it derives would be vastly different from what you thought your intent was. But when you simply express intent from experience, you don't really know what you wish, right? Because your requirement specification is your concentrated thinking, and the more detailed you specify the requirements and the harnesses and the way you actually bound and control the AI delivery, the more clear the product becomes in your head, and the more clearly you can express it, the easier it is for agentic AI to deliver. Otherwise, the agents will guess, and in most cases, practically in all cases, they will guess wrong. Not because they are flawed as systems, but because the specs and the constraints which went into them were not developed enough. So there is a question of assurance and verifiable trust, which built not on institutional trust, but on verification. And this is where Web3 comes along, where you can anchor certain things which are immutable, and that's how you can provide assurance to the outside world. I mean, the computational costs of this assurance still remain fairly high, but these costs are coming down. So governed and assured AI systems are becoming a reality, I think, as we speak. And obviously, the leaps and bounds of development of this technology change the industry, I think, every few months.
Yeah, it's very fast paced, obviously. You talked about intent, and I personally, I'm curious about your opinion here, because that, from my perspective, I would dare to say it's an issue we have had before too, but now it's a velocity, like the velocity of code generation emphasizes that issue, right? Because you formulate the intent, the specifications, and you get the output quite fast or immediately. While in the past you had to wait weeks, months, and intent got obfuscated with new messages, like new requirements in between and things like that. What's your thinking pattern here, your opinion?
Well, I think it still takes time to formulate intent. Delivery may be, compressed massively by AI, but formulating requirements, formulating and defining and devising intent, making sure that the product, what you are designing, actually makes sense for your organization, for your external customers, or internal customer, that takes time. And this cannot be outsourced to AI. Some of the aspects can be outsourced to AI, aspects of documentation, but the thinking process cannot. And obviously, we do have a validation constraint, which is a hard constraint of people who have to validate whatever AI produces. Basically, shifts the responsibility up the stack. So at the level of intent, when you generate requirements, when you generate constraints, yes, AI is also helpful there, but in the end, it's up to the humans to review and decide how to proceed. Now, the same constraint applies during the generation, because generation happens very fast. And sometimes what we face is that we need to have enough time, enough human attention to read the documents which AI can generate as projections of our system. And obviously, that is a massive challenge, because AI can generate tens and hundreds of pages very quickly, but then you have to read, absorb, and understand it in order to decide what actually makes sense and what doesn't. And obviously, without that layer, it becomes nonsense. It basically dissolves in chaos eventually. The same with the code-based delivery. AI generates code very quickly, but it has to be reviewed. And without this human review, it doesn't really work on a sustainable basis, because even 5% or 1% of faults propagate in the end. And I think an example by some of the companies like Stripe, how they combined traditional governance with AI and actually made it work. In their case, generating over 1,000 pull requests a week, which are human reviewed, but obviously generated at considerably less cost than they used to have, and obviously building on the existing governance architecture, which helped them, put out hundreds of thousands, millions lines of code over, 2 decades, or a decade and a half. It makes a very good example of implementation, and we can all learn from it. And also, again, there is no rocket science about it. If you treat AI as a participant, as a first-class citizen in production, you need to think how you govern AI. Now, there are fundamental laws of governance. So one of them is Ashby's law of requisite variety, where the governor has to exhibit at least as much variety as the system it governs. AI produces a very high variety and very high variability of outcomes. So whatever governance system you put in place, combination of humans, AI, policies, procedures, whatever, smart contract has to exhibit at least as much complexity and variability to manage it correctly. If your governing system is less complex than the system you try to govern, again, it dissolves into chaos, and obviously there are only two solutions: either it implodes or you have to dumb it down, or basically give up on the use of AI, which is a shame because it offers massive increase in productivity. So there are no easy solutions, and it's kind of, when you save in a certain area, you may have to invest more in some other areas, but overall, it can offer massive increase in productivity if properly done. It can offer much more rewarding work for the engineers, who are basically refocusing from writing code to actually conceiving and designing things, which is what everybody wants to do as an engineer. They want to be designers, they want to be developers, in a sense of developing, not coders necessarily, although some people derive pleasure from it. And I think it also makes a lot of commercial sense for the enterprises to do it properly. Because once you have a system which works, and once you have processes which work, you can actually scale the software delivery. So it becomes scalable across the organization, also across the product portfolio you run, which is important, because then that's how you spread the costs. Because again, governance used to be an incredibly, and you can basically, and again, I've spent 2.5 decades practicing governance, working with governance in sort of traditional enterprises and of late in Web3. But fundamentally, there are two types. There is a kind of natural governance, the endogenous governance, which evolves naturally within a system. There is engineered governance. We're talking about the engineered governance, and obviously it takes an effort, it takes money, it takes time to invest, it takes human beings, obviously. And you want to spread these costs, and you want to amortize them as wide as possible. Otherwise, the cost of engineered governance sometimes outweigh the benefits. That's when the governance doesn't get implemented. So that's not an easy, not a one-size-fits-all solution, but I think everybody can find these incentives and constraints for their own organization, map it out, design. Yes, it does take effort, but everybody does in life, so it's not necessarily anything new. No silver bullet, but a lot of improvements, and quite exciting for builders, I think, in the next few years.
Yeah, I mean, the opportunity is definitely here because uh, almost nobody truly knows how to operate this right, because it's just uh, so fast paced, everything. It's difficult to put processes, also guardrails, processes, governance in place when things might change, right? It starts yeah, with A and ends with Z. uh, you mentioned specifications, requirements engineering basically, and QA. Obviously both are super important. If you would need to make a bet, which one of those would you argue is more or of higher value for corporate organizations in the future?
I think both, because actually you cannot define QA without requirements. I mean, they're like twin brothers, right? You can't remove one from the other. So it's almost like a moot point. I think it is easier to generate requirements and produce requirements now with AI than to do QA, which still involves a lot more human effort, but obviously it is also being operationalized by AI. So I think fundamentally, if you kind of step up a ladder a little bit, it's the governing of these processes which is becoming essential rather than the execution of the process themselves, because the execution is being progressively outsourced to machines. Whatever can be codified, whatever can be defined, whatever can be effectively put on paper, which involves, fairly, standardized processes, is all going to machines. Whatever involves a lot of human discretion will remain with humans for the foreseeable future. And that's the most interesting part. So I wouldn't really put one ahead of the other. I think both are important. If you don't have requirements, there's nothing to QA on, because how can you QA against something you don't know? And this is something, obviously, which a lot of projects discovered because they haven't invested in requirements. So there is no way they can check whether the software actually verifies against something which doesn't exist. And on the other hand, if you don't have QA, if you don't, obviously, how do you know that whatever is built basically makes sense and meets what you've intended to through requirements? So both are important. I mean, the governance part is incredibly, I guess, critical in this particular transition, because we need to make sure that things do not get forgotten. We need to make sure that process design is again given this rightful place, which connects all of these different frameworks, all of these different tools: human execution, human quality assurance, mechanical execution, mechanical assurance, linting. Whatever, I mean, in one seamless process, which has to work and which has to deliver and which has to actually, again, be auditable and provable to third parties. And that takes an effort.
Yeah.
I don't think there is much way around it. And again, if you try, I mean, from experience, having worked in many different industries over last 35 years, I can say that process design is probably one of the best investments you can make in a business when you know what you are building. Obviously, first you need to know what you are building, but then how becomes very critical.
How would you sell process design to an enterprise or to an organization who doesn't properly implement it?
Well, if you don't want to implement process design to begin with, there's probably no point of designing. But I think, it starts with understanding what the organization is, and what again happened over the last 3 decades, which I have progressively watched, is how people outsourced thinking to tools. Because in the past, 30 years ago, designing ERP, which I was involved in, was an in-house process. You actually first map out your organization, you understand what the flows are, what the requirements are, and then you would design the system, which was bespoke for yourself, but would actually allow you to manage this enterprise. It wasn't perfect. It was obviously a lot of challenge. It was costly. It was not necessarily efficient, but it actually was building a system which was fit for purpose. And then all moved into the tooling. So you had all of these massive ERP system providers who designed one size fits all with a lot of very expensive optimization options, because that was the business model, where you would in the end spend a lot more money, time, and effort on integrating this system than probably designing your own in most cases, save for a few enterprises which kind of were very, very run of the mill. So the first thing before you design any software development processes, you have to understand your organization, and you have to have a disciplined organization. And this is very tough because it starts way before any IT, whatever technology considerations. Because having a disciplined organization, having a well-governed organization is a challenge, and it's a cultural shift as well. And not all organizations are ready for it necessarily. So if your organization is ready, if you are prepared not just to have manuals somewhere on the shelf for the show for the regulators, but you are prepared to design processes and to live by them, then obviously it's fine. Then the software flows out of this naturally and almost necessarily. But if you don't, I mean, there's no point of trying to kind of bolt on the software process. It wouldn't work. It would basically be just for a show, really.
Yeah, it's I see a pattern here, right? It's actually quite similar to all these companies now just throwing AI at their existing products without actually applying AI at the, I wouldn't say foundational level, but at the from an architectural perspective, that it's actually plugged in the right way, if you know what I mean, right? It's not
Yeah.
like, okay, let's put a stick on it, we use AI, we're an AI company, but actually use it to create value. And that basically brings me to the next point that you already scratched upon, and that's technical debt, right? Obviously, it's very cheap now to generate tons of code, and people still, or engineers still review code, but a lot of engineers don't. How do you look at that from a process and lifecycle perspective?
What's the real challenge we're dealing with right now? And obviously, code generation has become very easy, very fast. Code specification can also be, or specifying the requirements can also be automated. So producing complex specs can be offloaded, part of it, large parts of it to a machine, but then the code as the end product you still need to review and validate. And obviously you can use AI to review and validate some of it, but in the end it's down to a human being to actually sign off. And the first thing becomes, okay, how do you actually integrate this code and continuous integration, continuous delivery, and what size of pull requests or merge requests you basically require, what kind of cyclomatic complexity. If it's too big and too complex, humans find it massively difficult to understand. Obviously, I can generate any type of code and tends to stack, and in the absence of discipline instruction and following tends to create these massive chunks of software which are almost incomprehensible. So you have to direct it, and you have to make sure that this comes in small digestible chunks which humans can review and validate in 10, 20, 30, 50 minutes, whatever, but within a very reasonable period of time, so you can maintain an attention span for a senior engineer to do it. And that's the only way. I don't think there is, again, any kind of silver bullet here that somehow you click a button, it all works. It is about discipline, but once this discipline is embedded and it's across the value chain, it's in the vendors who deliver you the code base, it's in the folks who validate the code base, and the folks who actually provide assurance and what have you. If it goes across the entire stack, then it becomes an acceptable norm, and then everybody works to the same standard. But I think the idea of splitting the code base, and particularly in this continuous delivery, continuous integration framework we all work in, is very key, because you can't overload humans with too much complexity, because when humans are overloaded with that, they miss things, and that's quite natural. So you actually do have to take anthropology and cognitive, constraints into account. Because too much code means that a lot, or too convoluted code or cognitive overload means things will get missed, which will then contribute to technical debt. And the technical debt, and what they call now comprehension debt, because if you accept something you don't understand, and again, it goes back to the first principle, don't do something you don't understand. If you don't understand the code base, if an engineer reads the code base written by AI, doesn't understand what is written, kill it, don't accept it. It's as simple as that. I mean, it's hard to do from a behavioral perspective, but it's a very simple rule. If you don't understand it, you can't explain it, you don't understand the logic behind it, you don't understand why it's done this way, why it's basically repeating itself 20 times in the same, just kill it, send it to refactor.
Yeah, that discipline part obviously like is always, I would argue, the key challenge in a lot of these organizations, right? Like not just enterprise scale, but also small organizations. Right here, obviously, the restrictions are not as strict, or even shouldn't be as strict, possibly, because you would just slow you down without a meaningful benefit from your organization size. But it's really interesting to see like what strategies evolve over the years to not fix that, but uh, alleviate the pain, so to say, right?
Well, AI has massively brought the cost down of discipline systems engineering, and I think we'll all benefit from it. It doesn't replace Agile, doesn't replace any other delivery tools and frameworks which have, but it integrates them all. And if we deploy it properly, and if we actually invest in it, I think it can provide massive efficiency gains across the industry. But for organizations, it means that you have to invest a lot of effort into thinking upfront, into process design, into governance, into maybe re-engineering not code-based parts of your organization. Again, for technology organizations, kind of easy because everything you do revolves around technology. Like what we are building at Polity is a technology organization. For some, maybe traditional manufacturers or whatever, FMCG companies, it may be more difficult because, again, their business is not necessarily software focused. The software is an integral part, but it does involve a lot of effort up front, and there is no simple way around it. I mean, there is a payback at the end, but you have to think long term and you have to plan over a long term horizon. This is not an immediate gratification. Okay, you put the process in today because it's simple, just click a button, everything works. No, it doesn't, never does. And I think this is something where people are kind of struggling with because, on the one hand, you want to have the results yesterday. On the other hand, a lot of people understand that it's actually quite a complex and multifaceted task and process to go through.
Yeah, that immediate gratification part is something that we don't just observe in software. It's everywhere, right? It's just human nature, as you said. Um, from a architectural perspective, how would you think it enterprise architecture changes with that?
Um, I mean, when we bring back systems engineering, first of all, enterprise software architecture becomes linked into the governance architecture of the enterprise. So it's actually the entire enterprise architecture with the software part being an integral part of the entire architecture. So you have to think beyond software. And in every enterprise and in every product, you always think beyond software because software is just one facet, one projection of a product. So when you think enterprise, you think about everything which actually forms this enterprise, all the components of this enterprise, be it human, be it AI, be it physical machine tools or whatever the case is, and you have to actually manage it as as a governor or as a management board or board of directors or whatever the case is. So this holistic thinking is obviously the first thing which AI kind of forces on changing because you can't change one part without changing the other contingent and related parts. It just simply wouldn't work. So it's almost like, forced re-engineering in a way. So becoming an AI native organization is not just bolting AI on existing processes, it's completely rethinking the processes which you run through and also changing the culture. And again, culture is very hard to change. Culture is entrenched. People are naturally slow. There is inertia built in. That's just our biological defense mechanisms, and that's normal. So it has to be worked through. I mean, there's again no easy shortcuts, but it will force companies to change because obviously it makes companies much more competitive, much more nimble. Again, this implements the principles of agility we talked about earlier, but at a different level. And I think the allure with this irresistible, so people will be changing. It's a lot easier to build a new AI native organization than to re-engineer an existing one, but I think both will happen.
Yeah.
It's just the way it is. I mean, it's like every technological change forced re-engineer of enterprise. We've seen it over the last centuries. Always happened.
Yeah. I mean, we have talked a lot about verification and governance now. Since your company operates mainly in Web3 in finance, What role does or could decentralization play here?
Decentralization is essentially in the very important part of governance, which is called assurance. And there are two types of trust basically. There's institutional trust, trust in institution, trust us we built well because we have SOC 2 and we have other certifications or whatever. We are respected, established enterprise, or trust us because you can verify, you can have a basic operation performed maybe in minutes or whatever, verifying that what you claim is what the client gets and the client can verify it. So when you have Web3, that means that this verification is supported by the fact that it has been immutable and is on chain, and we can't really tamper it. So once it's out there, it is out there. So that verification layer is very important, particularly in the regulated space, particularly, we deal with governance, we deal with compliance, and that's the focus of what we're building. So that is absolutely critical to regulated or critical industries, and finance is one of them for sure. I mean, it may not be so important for consumer applications, and again, nothing spreads at once. First, it comes to have more heavier regulated industries, more critical industries, and then when the costs come down of this zero knowledge proof general verification, then obviously it spreads to other parts of the industry. I mean, for us, Web3 is essential, and without having these three components, systems engineering, AI, and Web3, what we are building would not be possible. Plain and simple.
Interesting. Yeah, I mean, obviously there are probably a lot of people watching or some people watching. What would you tell engineering leaders, engineering teams, what they should prepare for now?
I don't know. I mean, it's hard to say. I mean, it's hard to give advice, but always prepare for change and always learn. That's the only motto I've been learning. I'm now learning from people half my age and probably even younger, and that's natural because we have to learn, we have to adapt to stay. It's one of our 21 founding principles is what we call Red Queen principle. Just to stay in one place, you have to run, but to get somewhere, you have to run twice as fast. So I think that's probably one of the things to consider. So we have to run fast, we have to learn, we have to adapt. And that never stops. You can never rest on the laurels and say, okay, well, now I'm accomplished, I've done it, the things can move on. Because, they will move ahead of you very, very quickly. So that's probably is general, but it applies to everything. It doesn't just apply to software. It applies to finance, it applies to governance, it applies to whatever, and even manufacturing. And manufacturing is changing massively now. I think we tend to overlook it.
Wow, hey Alex, thank you so much for sharing all that wisdom and your insights. Before we end this session, do you have anything else left to share that you think absolutely needs to belong into that stream or live session?
Well, thank you, Kevin. I mean, the only thing I can say, these three articles we co-authored is just the beginning. There will be more comments, so stay tuned. And we would like this to be a discussion. We'd like this to be a learning discussion. We'd like to hear from engineers, from business leaders, from purchasers of software, or like at every stage of the value chain. Hear from people who actually face similar challenges, maybe have similar or different solutions, and learn together. That's what I would like to have, and this is how I'd like this conversation to develop. And it is very specific, obviously, so it's an industry conversation, but we would like to broaden it as much as we can. But thank you very much, and thank you for the opportunity today. It's much appreciated.
Pleasure is mine. Hey, thank you, Alex, and thanks everyone for watching.
Yeah. Thank you, everybody. Thank you for your attention.
Okay. So.
Well, thank you.
Yeah, to you. Thanks, Alex. Just waiting a couple of seconds before ending the stream. But yeah, looks good. No technical difficulties, as it seems, which is great because live streams tend to be messy in that
Yeah, I
that
was
sense.
concerned because this is my first, kind of TV appearance or whatever, live appearance over 25
Yeah.
years. As I mentioned, I did it in the past when I was much, much younger, and then I haven't done it for like over 2 decades. So it's a bit of a new thinking pattern as well.
No, it's you did great. I mean, I learned a lot myself, as always, and yeah, I'm just seeing the video in front of me right now. Looking forward to your feedback as well, but I think it worked really
Cool.
well.
No, it's great, and obviously, as discussed. I mean, we are not on stream now,